5 years ago, I TIG welded and made my very own hardtail mountain bike, and it is one of the coolest things that I have made in my life to date. And I've always had a soft spot for bicycles. Well, when I found out that the world famous Brompton folding bike, oh, that's convenient, is made right here in Great Britain, well, we had to ask them if we could come see how they do it. And so this is Brompton Bikes. Look at this place, this is incredible. This speaks to the inner child in me, watching how it's made on Discovery Channel. I mean, I dreamt of walking around factories like this. So now we're gonna meet Nigel, learn about some of Brompton's history, before we learn about how they build these bikes from scratch. I'm gonna learn some brazing, because these things are brazed, not TIG welded, and then we'll assemble our very own. Nigel?
Nice to meet you.
Very nice to meet you. Thank you very much for giving us a tour around.
You're welcome.
What's your background at Brompton?
I came the beginning of 2006. We were a company of 50 people making 13,500 bikes. We couldn't make enough bikes. We had extraordinarily long lead times. I came to work for Will, who's now our CEO. He gave me a clean sheet with a job description that said, teach the company how to make 50,000 bikes from our site at Kew Bridge.
So when you came in, they were making 13,000 bikes a year.
Yes.
And your job was to increase production to 50,000 bikes a year.
Yes.
How long does it take for a bit of tubing to go from a bit of tubing to a finished bike now?
Probably 2 or 3 weeks. Everything now flows. We have individual bays, we have 62 bays downstairs, we have 51 brazers, and we changed the way we work, and the idea is it should be single piece flow. We have 14 different skills that go into brazing the steel frame. We obsess over the quality of our brazing. We want beautiful quality, and we want it at a nice steady pace. You won't see anybody sprinting or running around here. There has to be a balance, and we choose to go for quality over speed all the time. In our best year, 2 years ago, we made over 90,000 bikes.
90,000 bikes a year. Wow.
So we'll start with factory A, brazing. Then we'll have a look at some wheel building. Then we'll go to paint. We'll have a quick walk past pre-assembly, and then we'll finish in final assembly.
We're here in Factory A, where all of the brazing happens, and this is the secret sauce to a Brompton bike.
That's it,
is
yes.
Incredible brazing and the incredible brazers that you have to do this incredibly skilled work, right?
Yes. So we'll start off with rear frames.
Okay.
So that's the rear triangle. So this is from the G line, the 20-inch model.
And this is a complex assembly to make. And to keep it dimensionally correct is not a given.
Yes, so we have seat stay assembly, chain stay, and tension tube. So tension tube is the first job that we teach anyone, which is being done just here.
I love these racks. These are beautiful. And these are all made in-house for the exact tasks that you need.
It's like adult Meccano. So you'll notice on this side of the factory, they're all silver. They're stainless steel.
Okay.
So when you put a hot part on it, it's fine. The rest of the factory, they're blue tubes, which is just mild steel with a nylon coat, because we don't want to put any hot parts near the nylon because we'll just melt it.
Got it. That makes a lot of sense.
So,
and of course, if there's something changes in a part, you can just easily adjust to this and get the sizing just so.
And everything's on wheels. So whenever we change the layout, you just wheel everything around. So you can see it's quite a simple braze all the way around. So we heat the tube up to 850, 900 degrees. When it gets to that temperature, we introduce the brazing rod, and the brazer will pulse. You're not melting the steel, you're simply melting the braze rod, and you want one little bead or you get it to flow all the way around. Very much like soldering. So it gives a strong joint. It's not the strongest joint, but the difference between brazing and welding is with welding you'll heat it to about 1300 degrees. The steel just starts to melt, you introduce the filler rod, and then when it cools, it's a very, very strong joint. But if it cools too quickly, it can become brittle. So to be safe, we would have to anneal everything. And bicycles have been brazed for 150 years now. So we braze.
And it is a beautiful technique. There's incredible craftsmanship in finely brazed joints.
So that's the next stage.
That's stunning.
So we're buying in the dropouts. So you've got the seat stays with the cross bridge. Back there was the tension tube. Then we just need the chain stays.
And so every single bay here is to do a particular component.
Yes.
You don't do two components of one bay.
No.
Every bay and all of this tooling is made in-house to braze together those particular components.
Yes, so the tooling is designed here, manufactured here, and maintained here.
It's incredible. And the ergonomics of every workstation are just phenomenal. That everything can be lifted, adjusted to the perfect height.
So the rule for when they're designing the station is you've got to assume that we could have, one day we could have someone who's 4'10".
Yeah.
The next day we may have someone who's 6'6".
It's got to work for everybody.
It's got to work for everybody.
Now, in the learning area of the brazing department, they're going to teach me how to do some brazing or some steel tube. Rebecca,
Nice to
thank
meet
you
you.
so much for taking
No
the time
worries.
this morning. I am so excited to learn about brazing. I once TIG welded a mountain bike frame, but I have never done any brazing of a steel tube, and I can't wait to learn about how it
Sorry
happens.
to disappoint you, but it's completely different. So
Yeah.
you'll have to start like everybody else.
Please do.
Knowing absolutely nothing, and then just grab the torch and the rod and go for it.
Perfect, and we're going to do some super basic beginning brazing.
Everyone
The
starts
same
with
type of
lines.
thing that you do on your first day on the job here.
Yeah, everyone, they call it lines, so everyone starts with lines.
Everyone
Just-
starts with lines.
Just simple lines.
Did you braze before you came and worked at Brompton?
No.
So you learn on the job,
Yeah.
and
I
now,
was 22 years old.
yep.
I'd worked for the company somewhere else, and I went to the big top man and said, "Why haven't you got a female? Like, I really want to try this. It's really cool. It's creative." Something happened. Somewhere went and made it happen, and then I became a brazer. And ever since I've been a brazer. So been doing it for a good, say, 11 years now.
Yeah.
12 years.
And
I
you
train
learned
everyone.
it all on the job, and now
Yeah.
you train everybody else.
Yeah.
That's so cool.
Yeah.
That's so awesome. Look at these beauties. I want a pair of these. These are fantastic.
So this torch ranges from about, I think, 1500 degrees, but we're going to work at about 900 degrees.
Okay. And what is the gas? It's an oxy fuel.
Yeah, so it's acetylene mixed with oxygen.
Okay.
We're the highest supplier of VOC for acetylene.
Yep.
And then we mix it with flux, so liquid flux, and it's all programmed into the whole system going in.
You've got the flux in the lines.
Yeah,
The flux goes in the line.
much safer. Yeah.
What? That is first for me. I've never heard of that. That's brilliant. And that's all mixed in that thing
Yeah,
there.
it's all safe, it's all been set up. There's certain people that are trained, including myself, to fill it and know how to regulate it properly. Also, what we need is lovely brass and zinc.
Okay.
So we've got a little bit of silicone in this as well to help it move and make it easier to melt. So, how do we braze? I'll show you. Let me just pop this down.
You're joking. You've got a remote there to adjust the height of your workstation. That is so good.
First of all, how we're going to start is we're literally going to do a simple thing, which is called a tack. We'll put the tip of the flame, which is the hottest point, and we'll melt it into a liquid, and then it will harden.
So
as
you're
a
really
solid.
aiming on the filler rod more than on the actual base material.
Absolutely, because
Okay.
it protects the material from getting hot. Once we've done that and you feel a bit more confident, we're going to do what we call as like the basic brazing technique. And we use this technique on all of our jobs. So what we're going to do is simply warm up the previous braze if it's there. If not, we just start fresh. And then we're going to move up and down continuously together. And what we're doing is placing the rod down, and the flame is cutting it, and step by step it's just making it lay in between the gap.
Oh, that is brilliant. This is
Just
so
gently. Take your time. The more relaxed you are, the better it is. Like that.
brilliant.
And then like if sometimes what we do with trainees, it's always worth giving it a go. We let you do freehand, where you try to manage the amount of braze.
Oh, brilliant. Just putting a bead on top there.
You put a nice little decorative bead on top. This is how we do our writing. So if you want to write a letter, you do it like that.
It's just gorgeous. We're about to see just how hard it is to make a bead that nice.
Okay, right, you ready to take over?
Oh, let's give it a
Let's
shot.
give it a go. When you're ready, we're going to take the flame and we're just going to light it, okay? That's it.
Okay.
So rod first. There we go, perfect,
good.
fantastic. You've done your first tap.
Yay.
So raise it. Here we go, I'm
Other
going to do
side.
another one. Yeah. Remember, you just want to melt the end of the rod, yeah? Which you get quite a large amount. Do a natural.
Delightful.
Okay.
That is very satisfying.
It'll feel even
Overheat.
better when you start doing ripples. So you're going in and in.
Love it.
and
You're such a pro at this that you can do it backwards, back to front, holding the tools the complete opposite way to show me. That's so cool.
Do you get a feel for it?
Yeah.
Because sometimes it's more of a feeling. So you're pushing the rod down into the gap and then up
Brilliant.
and then up. I'm going to let go
Yeah, no problem.
and let you do it on your
Try
own,
to cool
okay?
down a little bit here.
Yeah. Push the rod more in. So instead of laying it, it's going to be feeling like you're pushing it towards
Yeah,
the
there we
flame.
go. Okay.
And to make it a bit more cleaner,
Yeah.
when you're pushing, like you're pushing this down
Yeah.
into it, yeah, like this, and then your flame is going to go up and meet it.
Flame
So
goes
you're going
up.
like that, like a crisscross action.
Okay.
There we go. It takes a lot of concentration.
Oh, this is great. Oh, I'm doing my first brazing. This is so satisfying.
Not bad. Not bad at all.
Oh, this is so satisfying.
There we go.
All right.
All done.
Chuck this over here. I've got way more rock sides on the side than on yours, where
Yeah.
you've managed to keep it cooler. And God, look at that bead. Compare that. This is a pro's bead, beginner's bead. Wow.
Do you want to have a go at the
Yes,
surface
absolutely.
bead? There you go. Not many people can do that straight away.
Oh, I love this. This is very, very fun. Oh, I'm happy with that. Oh yeah. This is great. I mean, I'm excited to see, like, because obviously brazing or welding on the flat is one thing, but then when you've got to get around tight corners, you've got these really interesting joinings of tubes to get around. It's a whole different ball game, right? So this is what a bay looks like in production.
In real
a
life,
little
yeah.
bit different than when you're teaching me, right?
Yeah, definitely.
Wow. Look at all of this material as it comes in. And this is your handlebar brazing jig.
Yep.
This is the tube. You can be
It all
brazing
slots
that to
into
that.
there, yeah.
Super. And then this jig here, you've got a toggle clamp.
Pressing
Oh, it's
it down.
holding it down into a
Yeah.
pin here. And that pushes it this way on that clamp.
Mm-hmm.
And this jig, is that made by your team over there? So all the jigs are made in-house. Oh, it's so cool. So you're putting the heat into the lug because it's got that much more size to it. It's slower to heat up.
Yeah, and it just won't stick to both sides otherwise. Okay, and I start at the corner so that the pattern is nice by the time I get to the main run.
Oh, so it does fill that gap really nicely.
The professionalism comes in when you have to deceive the customer. They don't know where you started and where you stopped.
That's the sign of a pro.
Yeah, so you go back to the last group and you start again. That you don't normally see in a training book. You can only learn it through each other. And join it together so there's no gaps or holes, or what we call little tiny holes, pinholes that happen when the air gets trapped inside it.
What a beautiful joint. It'll be so cool to compare how easy you made it look compared to how bad
So
this
I
is going
can
to go.
fix anything, so you can just braze it and
It
then
might just go to the scrap pile. Okay, preheating the lug. Alright.
turn the jig completely, so you're at the corner and you just go
Okay,
from
then,
there
a little
to
bit
there.
higher up.
Yeah. There you go.
Whoa! I put way too much down.
It's okay. Not bad, not bad, not bad. Keep feeding it. That's it. Perfect.
Wow,
Not
that
bad.
is so much rougher than yours. Oh, getting it too hot, aren't I?
It's just where the tube got hot.
All right, there we go.
Brilliant.
We made our whole way
fantastic.
around.
So not quite the same as mine.
This is yours, and that's mine.
Not bad for your first
Oh,
go.
but the difference
I've
is
seen
so
worse.
obvious, isn't it? So from your first day on the job in the brazing department as a brazer, where you're doing what I was doing, how long would it take you to then be put on to jobs like this?
Average is about a year.
About a year.
Yeah.
Well, thank you so much
You're
for
very
teaching
welcome.
us about
Yeah.
brazing. So grateful. Coming from the future here, because I just want to talk about the history of Brompton. It's so inspiring, especially for me and all of you guys watching, because in 1975, Andrew Ritchie came up with this design and he started the company by himself, like proper from the ground up in a one-car garage. Incredible story, especially when you see the scale of manufacturing it is today. That's what's possible when you've got a great idea, and when you can build a great product, and when you can sell a great product, which is exactly why I think that you should go and check out Squarespace. It's a website building platform that we absolutely love because it's got countless drag and drop themes. You can sell unlimited physical or digital products. Just imagine how difficult it would have been back in the day, in 1975, to sell your bikes after you spend all this time and money designing and manufacturing them. Well now, if you've got an innovative idea and you've produced it, you can build yourself a Squarespace website. It'll take you like an hour or two, and from there you can sell it anywhere in the world. You can even manage your email marketing campaigns. The options are limitless, so please go to squarespace.com/forge. You're going to get a 2-week free trial of their amazing platform. Drag things around, experiment, build something beautiful, and then code FORGE at checkout will get you 10% off your purchases with Squarespace. That's squarespace.com/forge. We appreciate them. And now, back to Brompton.
So this is the bottom bracket assembly. This is the seat tube, the seat clamp. This is where the seat post will be. The rear frame, that rear triangle, pivots around here. We're going to cut the threads in here for the spindle. This is where the crank will go with the chainring, so you'd be pedaling here. So this is the last job that we teach anybody. There's about 8 minutes worth of work in here. And then you've got the frame number on the side. So this tells us this is 1,252,994 bikes.
Oh, it's a chronological serial number.
So we've got a different brazer, same beautiful quality, and the initials CD is stamped in the bottom.
So every brazier stamps their initials
has their initials stamped in the bottom.
This is awesome. So if you look on your Brompton bike, you can see the initials of who brazed the bottom bracket.
That is the most complex of the 14 jobs. When it comes to hinges, we want the strongest joint possible. This is external brazing. We have an internal joint for the hinges. So we'll go see that next.
Super.
So there's some maintenance work going on, but we have two of these auto braze machines, the main frame tube and front frame tube. So this, you'll recognize on the bike, will have the curve in it. But what we want is the braze on the inside of the joint.
Okay.
It's a much stronger joint if it's on the inside rather than externally. So up to 2002, someone would take the hinge, put it on the tube, and they would patiently heat it up and put a bead of braze all the way around, much as we've seen over there. I can't remember the cycle time. It was so ridiculous, like 12 minutes, because this acts as a heat sink. So then we introduced auto braze. The trouble is no one makes an auto braze machine because no one's doing anything like. So we've had to always find partners and work with them and get the machines made for us. So this is about Mark 5, Mark 6.
Wow.
What we do is we now buy the tubes in from the mill in Spain. They'll machine the ends for us. This end, we used to have a 30-ton press. It stood about as high as this tray above our heads, and it used to scallop the end out so that it would meet the seat tube. And every time it would come down, the floor used to shake, and the burr would be out here. And we had two guys with gardening gloves and a file, deburring all day long. And no matter how hard they tried, you would always end up with some sort of burr, and people were cutting their hands. So when I got my first production engineer, I said to him, find me a better way of deburring this. And off he went. And he came back about 6 weeks later and he said, what do you think of that? It's very good, isn't it? So I said, well, how did you do that? He said, that's done with a laser. So I said, great. How much is a laser? The laser would be £85,000, and it was so fast it would cut all our tubes on a Monday morning.
No, then you don't need the laser here.
So it's a great solution, but wasn't going to work for us. So we got stuck, and then we were having one of our weekly meetings, production meetings, and someone who had nothing to do with that actual project said, well, why don't you ask the mill? So we called the mill up, explained what we wanted, said, look, this is what we'd like. Would you have other customers that would like that service? Would you invest in the laser, and we'll sign for however many years of buying our tubes from you? 2 weeks later, he came back and said, the laser's on order.
And that was a brilliant out-of-the-box way of solving a solution.
And that was 17 years ago.
And now that same mill is still...
They still supply...
They're providing this. They've got the tube laser to...
And the front frame tube.
Do that.
So they're identical. So the mating part is the hinge. So you have the main frame and the front frame hinge. They go together like that. A pin goes through the middle. And then the other side, it just touches on these two pads. Okay. We're not looking for it to touch all the way around. The hinges came from a mill in the Midlands, and we had tiny little pock marks on the outside, and we went to see them and we said, we'd like a smooth finish. We want to make the most beautiful folding bike in the world. And they said, oh, it's down to the flow process. So eventually we found a mill in Poland, and they have a much better flow method. When I came, we had a series of milling machines, so we would machine the faces, the bore, machine the bore in here, this face, cut the thread, and the same on that one.
Don't tell me the end of this story.
Go on.
Is it the mill in Poland that makes these, that now has the milling machine?
Yes.
Machines these to the finished
and they rumble them. We used to rumble them as well. So they come in ready to go. Now on the bore, you can see this is 5 millimeters deep.
Yep.
So if we can get the braze in there, we have a really good contact. So we machine it out, and then one of our little secrets is when you put the brazing in,
Brilliant.
You can see that the tube will only touch on 3 points.
Oh wow.
So
so it'll be a perfectly flat plane every time.
They load them on, they line them up, they have a little A-frame that comes to orientate them, and then there are 3 heating stations. The first station warms it up, the second station gets it to the 850, 900 degrees, and the third station controls the cycle time. So you've got pyrometers here that are measuring the temperature.
Whoa.
So we've broken it down into 2 warming stages, and then this is the one which produces the cycle time, and it's a capillary action. So you've got, I think it's 7 torches 6 or 7 torches on each hinge, and it flows and it comes out, and you get a nice line of gold braze all the way around, which I'll show you next.
Are you able to share how expensive this machine is?
It's in my notes. It's got to be somewhere near £250,000.
£250,000 of custom machinery for brazing these things.
On here, they don't come off ready to go. We have an extra op. They go in there. These are vibratory bowls, so it's a ceramic stone and acetic acid. They go around for about 20 minutes, and when they come out, they then go back this way. So this is your rumbled hinge. Okay. Then it goes on the press. The form is in the top. This is a 10-ton press, and the bottom is sprung loaded. So obviously you need to orientate the tube. So if you can see, you've got the cutouts at the far end. Yeah. And then you push the button, 10 tons of force.
Gorgeous. In here is the tool room where they make all of the tooling to be able to make these incredible brazing jigs. Oh, this stuff excites me. Thank you so much for giving us some of your time to tell us about the tool room. As soon as I walked past here and I saw these fixing cabinets, oh my God, look at this. Wow. It's like, there's more important things to talk about, but for anybody that makes stuff, just having that sort of a fixings catalogue, ticks all the right boxes. But anyway, the bit that I'd love to ask you about is the making of these incredible jigs to braze these frames. What's that process look like? Like, how do you go from step 0? You need to get these 2 tubes in the right place. What are some of the things you're thinking about to get that done here?
Well, the design team, they come up with a design. They send us the CAD for the tubes themselves, and then we kind of build around it. You know, this 50-year-old company. Now we've got like a base model of the bike jigs. We can kind of adapt them for, like, say, the larger wheel, take an inspiration from the old jigs and stretch them out, basically. All these different clamps, we have all our different standard parts, all these sort of clamps that go in and around. This is actually correct for this jig. That goes in there.
Are you designing these jigs in CAD from the CAD drawing here?
Yes, we're looking at the CAD of the part, and then we'll say, okay, we need to make sure that these tubes are clamped securely down, because we have to think about the heat distortion. Finally, you get a nice, good clamp on everything.
And so how much of this jig here, how much is made in-house?
Because of the growth of the company and the amount of jigs that we produce now, we outsource all the machining. We still have our beautiful mill and lathe. So every time we make little changes to the jigs, we have to add a little hole here and there or machine a little bit off. You know, we do that side of it, things in-house. So this section, the jigs, they get covered in flux, bushes wear out, clamps wear out, so they need to be replaced. So we've got a nice team of people here that strip them all down, take them all apart.
Don't you just want to, like, hang this on your wall as a piece of art? Once you send off a drawing, how long is it until, like, you're now assembling the jig to then, you know, put it together for it to be tested?
It can be somewhere between 2 to 3 weeks. If it's a large jig, you know, with lots of components, then you're waiting 6 weeks or so.
Wow. Thank you so much for sharing your workshop with us.
Nice to meet you.
Such interesting work. I mean, this just tickles me in all the right ways. You know? One final question. Average jig, how much does it cost to get made?
Something like this. These are probably £8,000.
That is crazy. 8 grand a jig.
So, wheels. We never had enough space to make our wheels before. And the wheels were good, but we would have the rims, the spokes and the hubs delivered to the wheel builder in the Midlands. We were spending £65,000 a year just to send a van up every day to bring wheels back. So when we came here, we had room, so we brought the wheel building in-house. So the first operator's laced the hub, the second operator offers a spoke up and it drives the nuts on. So they're a T-shape. Then he rolls it down the line.
Oh, he literally rolls the wheel down the line?
Yes. So it's going to roll down.
That is brilliant.
If this is running today, it will put the rim tape on. Oh no, we haven't got any rim tape. But this machine is capable of putting the rim tape on, and then from there, the wheel rolls down. We're making 500 bikes a day, so that's 1,000 wheels. Another 200 wheels for spares for our customers. 1,200 wheels a day. So the clever bit is the truing. That's where the skill lies. The wheel will come in, it goes around, there's a pair of lasers left and right, and another pair for up and down. It finds the shape of the wheel, so the fingers come in. and they tighten and loosen the nuts as the wheel goes round to get the wheel true and the right tension in the spokes. It does it in 100 to 120 seconds.
Wow.
And then they roll off, and again the picker will come along, take them off the end of the track, and they're ready to go to the stores. So with the wheels, generally we'll be building a wheel 2 to 3 days before we use it.
So it only hangs around in existence for 2 or 3 days?
Because we want to fill our 94,500 square feet with production. We don't want to fill it with stores.
The warehouse, relative to the size of the workshop, is very small.
Yes, when I came at the previous factory, it was over a third of the size of the factory.
So all the frames that we saw get brazed together, they get cleaned, they then go to your painting department.
Yeah, so they'll run along the back of the stores. We're not allowed to take any photos in paint.
Okay.
Because we powder coat. So the powder is very, very fine. It's an electrostatic coating. It has the same consistency as flour or talcum powder.
Right.
So the manufacturer tells us that if there was a spark, there could be an explosion. So the paint plant is much like a server room. If it sees a flash, it will dump gas to suck all the oxygen out of the air. So from this point here, we say no photos.
Okay, right. So we can go, painting happens over there.
And here in the round decks, so this is about £190,000, 3 Paternoster storage systems. So the paint comes off, you go here, you tell the machine what you're going to put away, it presents the box tray to you, and then when you come to do the picking, the system presents the parts for you. It says take 5 from this box, take 3 from this box.
And so this is filled all the way to the ceiling.
Yes.
with
there are
products.
these 3 lifts will hold 1,500 frame sets.
Oh my goodness.
So there's 3 days worth of production sitting there.
These systems are something else. So now on to assembly, and this is another place you've made a lot of efficiency improvements, right?
That goal was 50,000 bikes a year. So that was 1,000 bikes a week. So when we went to a 4-day week, which I strongly believe in, that became 250 bikes a day, and they gave us our tack time of 4 minutes. By 2013, 2014, it was 4 minutes, and by the time I finished the end of 2016, it was 3.5 minutes. It's now 1 minute 38.
So when you say tag time,
The tack, T-A-K-T, is the cycle time. Each station, there are about 16 stations. It's 1 minute 38 seconds in each station. And to get that, we stripped out every job where we didn't need the bike physically there. So this is what pre-assembly is. So here they've put the lamp onto the bracket, onto the rack with the roller wheels on. Here they're putting the mudguard stays onto the mudguard. These are the sort of things that would be done in a bay before, sucking up all that time. So we stripped them out. There's 108 pre-assembly jobs, leaving the bike builders free to build bikes.
wow.
So we go this way. So it's in a classic U. It starts at the beginning. It comes up. You always pass the work from left to right, anti-clockwise. So the pink is on there, and all the details are on there. So they come along, they scan it, it flashes up on the screen what they need to do. And then because you haven't got every part in every bay, you've now got space. And we've got a chance to put some decent ergonomic tools in. So some of these tools, where we do the very important torque settings, they will record the serial number and the torque. So for instance, when we put the cups in, right hand and left hand thread, and say the torque is 32 to 35 Newton meters, it won't change direction to do the next cup until it's got to the right torque.
These guns with the torques on them, I mean, this stuff's got to be incredibly expensive kit.
That one isn't. The ones that put the bottom brackets in are about £12,000 a pop.
Wow.
The end line is where we make the steel bike. The middle line is where we make the G line, the 20-inch gravel bike. Here we will make electric bikes, which is what these are, the titanium bike, and the P, the super light.
Thank you so much, Nigel.
You're welcome.
I really appreciate
Pleasure.
it. So now it's about time for us to see the assembly of my Brompton bike. Jesus, thank you very much for your time today.
My pleasure.
You're going to show me how we go from brazed, painted, pre-assembled bike frame to putting all the components on.
Sure. So that's the fork.
How long have you been working at Brompton?
23 years almost, so 22 and a half.
Wow.
So yeah,
that's a long old time.
It's a long time, yeah. So this is the reference spindle. So as you can see, that folds nicely. Clicks into the reference click.
That's the locking mechanism.
Yes. So I'm building the bike like old school, like all hand tools in the past. On the line they're more like drills, guns, you know. Tool guns, things like that.
So we're going to go align the handlebars with the wheels. Oh, look at this. That docks it in place so it doesn't move.
Yeah, and then we have a lever here on the jig. locks.
No! And then it clamps it so it doesn't
Yeah.
move at all.
And you lock it, yeah. So you can
That's
work
so
nicely.
cool.
So this is the handlebar jig. So it has a pin with a lever. You have to fit that inside the handlebar hinge pin, release it, and it locks there. And now you got the handlebar straight with the wheel.
And so the whole design is such that when it folds, when the handlebar touches the wheel evenly, it is going to be straight when it unfolds. So
Yes.
this jig works around that pivot point. Boom, you know it's lined
Yeah.
up. We can now tighten that Allen screw that
Yeah,
we
yeah.
saw earlier. So this will calibrate to the torque that you need.
Yeah.
Look at that beaut. Atlas Copco. You know that's expensive. That is awesome. So the computer will program this
Yes.
just what,
To the right torque.
to the right torque for
And you-
that particular job.
Yes, and this tool you can use it for 3 or 4 different jobs. Just by changing the bit here, it will give you different torques.
You're
So
joking.
that will read the torque that you need to use to the program. And this is, for example, it's 18 newtons for the wheel. Then you use a different socket for a different wheel, 30 newtons, and that one for the
And so
front
just
wheel.
by putting a different socket in this,
It will change
the
the
torque
torque.
reading that it gives.
Yes.
And you can program that. You could theoretically program that different for different sockets.
7 different torques, maybe, or
Wow. Super cool
Yeah.
technology for a production line.
8. So that's it, the rear wheel. But you have to make sure you put the other one back.
That was a catch and a half.
That was a good catch.
There we go.
So we're gonna do the handlebar now. That's it, green light, that's what you want.
Rail up there as well, so it
Yeah.
slides.
So now we got the handlebar straight with the wheel. Okay, we can go back. Yeah, those tools are pretty expensive
They are
tools.
super cool. Can you imagine how expensive they must be?
Just the tool is about 10 grand, 8 grand. Just the tool.
10 grand per drill.
Yeah. Now we're gonna do the cranks. Yeah. So we just need to tighten this on the line.
30 Newton meters coming right up.
Yes, oh, you remember, yeah? Keep going, yeah, perfect.
Green light.
Turn the bike upside down again. You wanna do it?
Oh, I'd love to.
So,
That's done. And even on the production line, a little bit of hose is just what
Protection.
needed
Yeah.
on the tool to make it not mar it. Oh, that is
perfect.
neat.
So that's,
Look at that.
that's your 30
Slides.
newtons.
So ergonomic.
And now we're gonna do the folding pedal, couple of turns, and just spin it.
Perfect. That's so cool. What is
So
that?
with this,
What is that? Look at the arm.
yeah, then you clamp it into the bike.
And so this is so you never have to actually lift the bike yourself.
Yeah,
Because if you're doing it day in, day out, they don't want you getting hurt. Wow.
and that will, you can move the bike around.
Wait, you just, with your hand and it
Yeah.
feels what you do?
Just move it around.
Wow.
It doesn't have any button or anything. Just by pulling it
That
to
is-
the floor.
Yeah, absolutely. It's
Try,
so
try.
sensitive. That's
Pretty cool, isn't it?
It's almost kind of like magic.
It is.
Yeah.
That's utterly incredible.
That one, it will release it. Yeah.
Wow. Whoa.
One finger, you don't need to do any strength.
Yeah.
So we make sure that's nice and smooth. That will lock in there, hold the pedal. You got the whole bike, one
That's pretty
piece,
slick.
nice, compact, cool. That's the saddle plus. That is your handle for the bike to carry around.
Oh, that's effortless.
We call this the pink because in the past it used to be pink, the color. So we
Now
still,
it's white paper.
and we still call it the pink. And here you have all the specification of the bike.
Yep.
So all the every single part that goes here is in there, country-wise, everything.
And
you
then
got
this follows the
barcode.
bike all the way through manufacturing and it
Yeah.
gets scanned in each department.
Yeah,
type
so
of thing?
I will have to scan this pink all along the line now
Okay.
until the end. So this is our laser machine. That's where we print all the plates that goes into the bike. Scan the pink here, ready to mark, and now we just press start. You look inside.
So efficient. Every single system in this place is just designed to be as efficient as possible, eh?
Open the door, get the plate.
Brilliant. Jesus, thank you so much for your
My
help.
pleasure,
Thank you
Alex.
so much.
My pleasure.
Well, I'm bloody happy. An enormous thank you is owed to the team at Brompton for having us and showing us how they make these awesome folding bikes, handmade in Britain with some incredible manufacturing processes. Really very inspiring and so exciting to see it. Please be sure to check out today's sponsor, which was Squarespace. At the link in the description, build yourself a website with them. For now, got to cycle back to Norfolk. You have to hitch a ride, Jamie.